We're now going to move into the relationship between moles and mass, or mass and moles. So the mass of 1 mole of substance is called the molar mass. So it has units of grams per mole. The molar mass of an element in grams is numerically equal to the element's atomic mass in AMU. So when you look up on that periodic table, that number at the bottom is going to use the molar mass and the atomic mass. The only difference is atomic mass is in AMUs, and it's the mass for like one of those things, where the molar mass is the mass in grams for an entire mole. So an example is carbon. The average carbon atom weighs 12.01 AMUs, therefore the molar mass of carbon is 12.01 grams per mole. I don't think your notes have the moles in there. If you're using the notes, it will print it off, or on the website. So the lighter the atom, the less mole weight, or the lower the molar mass. So carbon is lighter than sodium, so 1 mole of carbon atoms would only weigh 12.01 grams, while a whole mole of sodium atoms would weigh 12.99 grams. And once again, that's per mole, so you do the conversion, the moles go away if you add 1 gram exactly. The molar mass of a compound can be calculated by adding up the molar masses of all the atoms in that compound. You need to make sure that you take into account how many of each atom they are and their own molar mass using the periodic table. So we can calculate the molar mass of water. We got 2 hydrogens, 1 oxygen. So we take 2 times the molar mass of hydrogen, which is 1.01 grams per mole, plus the mass of 1 mole of oxygen. So you could put a plus 1 times there if you always want it to be consistent. And add them up, and so the molar mass of H2O is 18.02 grams per mole. So every mole will weigh 18.02 grams, and if you have 18.02 grams, you'd have 1 mole of water. So we're going to go ahead and find the molar mass of 2 different things. We got magnesium phosphate and antimony 5-carbonate. So the first thing you have to do is you have to figure out the chemical formulas for those. So these are both ionic compounds, so you're going to have to do some charge balancing. So magnesium is Mg, has a charge of +2, phosphate is PO4, charge of -3. So we're going to end up with a formula of Mg3 PO4 2, so that we have a +6 and -6 that cancels out. You can do all this on your calculator, but I'm going to try to show some work and then just give you the answer, and then make sure you can do this consistently, because you have to do it quite a bit in this course. So magnesium, I look up on the periodic table, I see its molar mass is 24.30, and I have to multiply by 3 because there's 2 magnesiums. Phosphorus, I look up on the periodic table, it's 30.97, and there's 2 phosphate ions. That means that there's 2 phosphorus, because there'd be a 1 here. 1 times 2 is 2. And then lastly, oxygen, look up on the periodic table, has a molar mass of 16.0, and there would be 8. To get out my calculator, I multiply those out and I add them up, I get 262.84. All these had 2 decimal places, so I'm going to keep 2 decimal places, and I have units of grams per mole. Antimony 5-carbonate, you want to pause and try to do this one on your own. If not, you can watch. So antimony has a weird symbol, it's a SB, find it on the periodic table. It's 5, so it has a charge of +5. I look up carbonate, it's CO3, has a charge of -2. The simplest number they both go into is 10, so I'm going to need 2 antimonies and 5 carbonates. Go through the same process. Look up the molar mass of antimony, 121.76. Multiply it by the 2 because there's 2 of them. Look up carbons, molar mass, which is 12.01 using the periodic table. I multiply by 5 because there's 5 carbons, because there are 5 carbonate ions. Now I'm going to do oxygen, 16.00 times 15. There's 3 oxygens in each carbonate. There's 5 carbonates, and that's a total of 15 oxygens. Plug that into my calculator. Get 543.57 grams per mole. you should go ahead and go back to the Schoology page, and you should watch this quick little video. Maybe it's not so quick. By Tyler DeWitt on counting atoms, and we'll pick up after you've done that.